How's it, guys? Another quick check-in. You've now completed module 1, and you've now just finished the non-insulated building systems, and you're about to start the insulated building systems, which is part 2.5 of module 2, and that'll bring you to the end of module 2. And then after that, we're not going to do module 3 yet, Yanisoft, but we're going to take you straight to the factory for module 4, and that we'll do when we come back. But for now, let's have a look at insulated building systems, and let's hand back over to Andreas. Thanks.
This presentation is built a little bit differently. It's actually designed for the architects to explain to them where the insulated systems came from, how they were born or developed. And this presentation goes back a couple of years. I will start with the foundation year of Janssen, 1932. This was the year when the first tubes and first profiles, well, actually in the 30s, the first profiles were constructed. Here you see Mr. Josef Janssen, who founded the company, the first team, the first rolling machine, the first testing lab, and then just the development of the company. This is one of the first brochures that came out. And what's interesting here is the profiles are not thermally insulated, but they feature a double glazing. So as you see, it's very similar to the profiles we saw from. They actually basically just glued the glass onto the profile. So this was the first step towards thermal insulation at Janssen. Must have been the 30s, yeah, before the Second World War. Mm-hmm.
Yeah, it's the same time Henry Ford was delivering on his motors.
Mm-hmm. Then 1940s, after the Second World War time. One of the metal factories that existed back then, and as you see here on the right-hand side, the brochure in French for the French market. The 70s, what do we have? Still lots of concrete. The buildings became, however, more transparent. And back then, the 60s, 70s still featured a lot of concrete, very monumental buildings. The 70s, already the first step towards building envelope. So facade systems came into the game. And this is also when Janssen started producing. Okay, there's a couple of just crazy slides that show what was going on back then. This was a celebration of 50 years of Janssen. The machines we used back then, this is actually original machines that Janssen used, the Telex. Yeah, here a Telex, blah, blah, blah. And 1973, the first insulated window combined with a facade. And here you see the principle, how we, well, actually, the facade is not really a separated system, but the separation, the Telmer break is nicely visible here. This is the inside, the base construction of the facade, the outside between the glass, and this fixing stud, or the fixation stud, is the thermal bridge. In the first thermally insulated profiles, the bridge was small, it was made out of plastic, and this is how we started separating the half shells. Okay, I'll skip these floppy disks. What also happened is in the 70s, the glass values became or grew or became much better. The thermal performance. We had the double glasses. We had the first inert gases filled, or so the windows were filled with these. And so also Janssen, or for that reason, any system supplier was forced to offer a insulated system. So this is how Janisol was born. Janssen insulated system, Janisol, that's the abbreviation. And the first system looked like the one you see here. 2 half shells, the insulators in between, still a separator membrane here, an aluminum membrane that creates 2 chambers. The more chambers you have in a profile, the slower the heat transmission or the cold transmission. And again here also in the leaf profile, a thick insulator between the two half shells. So this is how we do it. This is how all thermally insulated systems work at Janssen. Two steel half shells and the insulator in between. The insulator can be either quite narrow, like in this case, and therefore the values, of course, not, let's say, mind-blowing, but still okay. The more insulator you have, the better values we get. For the HI system, for example, we will get values of 0.9, 0.94, so considerably better with this. The more insulators, the better the insulation. Here an example of Yanisol windows. Concealed fittings or visible, everything was possible from then on. The Yanisol system was actually based on the economy. It was just separated. The 70s were really the year or the decade of the birth of these separate or thermally insulated systems.
Yeah, lots of innovation.
Yes, exactly. New materials came also into the game. The plastics have been improved. The fiberglass came into the mixture of fiberglass and plastic, started hitting the market. So we kind of rode on this wave. The 80s were the crazy decade for architecture. As you see here on these examples, some star architects, realized projects that we would probably not do anymore today. Here, the Piazza d'Italia in Barcelona, I think this is. And so a lot of kitsch. The phones became smaller in this decade. The first Commodore came out in the 80s. And the glasses became thicker and more, let's say, got higher performance. Double, triple glass with inert gas. Of course, this was the future. And Janssen followed. We came up with the Yanisol Primo. And you can already tell the insulator section is much wider here. The leaf still kind of remained unchanged, but the frame profile was much better insulated or separated, and the values, of course, dropped to 1.5 on the Yanisol Primo. We still have this profile family in the portfolio. A couple of examples of Primo windows. Glazing variants became much more diverse. We came up with lots of different glazing beads, as you see here, and nicely visible also the fastening of these three types of glazing beads. I described the stud system to you, the clip-on system, the spring system, screw and spring, and then the drill-through system for the contour glazing beads. These are actually the three systems we have in the portfolio. Glazing, left, right, center, this is all up to the customer. Okay, still the 80s. Kajagoogoo, Limal, I don't know if you guys remember this. This was the first songs I recorded as a kid. And now we are actually in the digital age. Our new leaders of the company, this is Priska Janssen and Christoph, the CEO. So a young couple of guys who lead the company towards the future. And of course, energy was the big word here. The CE standardization process hit really the European Union. The CE is a certification mark for that reason any product that is sold in the European Union, and it determines or describes the minimum requirements for a product category. So for windows, doors, and facades, here you will find, for example, the materials, the thermal values, forces, and so on. So this is what needs to be fulfilled when you want to sell in the EU and follow this minimum European Union standards. This is an example of how a window is tested for its thermal values. We have a defined element size. We have a defined UG, so glass value, and also the ceiling. And if you want to get, for example, to the passive house standard, the whole element must reach a value of below 1.0 watts per square meter Kelvin. So this is the requirement that the EU introduced in the 80s already. The countries, and this is now what comes in what you, Dave, said, it depends on the country whether a system can be used for the outside application or not. As you see here from this table, there is many countries in Europe that will be perfectly suited for the non-insulated systems. Italy, Malta, Greece. So these are the countries that probably use it anyway. But also France. I mean, the further south, the more flexibility you have. The different labels also hit the market. We have a lot of them. Well, we follow most of them. The passive house is one of the standards that we have covered with the HI profile, Yanisol HI. UG value, as you see here, has been dropping constantly. At some point, we will hit a let's say a rock bottom. But today, I mean, glasses with 0.4 are nothing unusual. 0.3, and this is what we also work with. The top of the line insulated system is our Yanisol HI system. Here you see a nice cross section of it, and it's nicely visible that the portion of the insulator is actually greater than the portion of the steel half shells. This explains the good thermal values. You also have 1, 2, 3, 4 chambers. So again, the more chambers, the slower the heat transmission or the heat loss. And with this system, we are actually really good here. When it comes to glass thickness, this was actually a calculation of what should we accommodate, what should we be able to accommodate. And in the end, we figured out some 54 millimeters is the thickness of the glass that we have to count on, and we have to accommodate it. So most of the systems will take this type of glass, triple glass 54. Here an example. This is the HI or this is the Yanisol. So Yanisol can take it as well. This is the cross section of, yeah.
I was going to say those energy values. You say it pulls through in Yanisoft as well. I can see it. Yeah.
Yes.
I could not understand you. Say it again, please.
He's just asking if the U values are available on Yanisoft, and I said to him they are.
They are. Yeah, the values will be inside. So you can calculate the value combined with the glass for the whole element. Okay, some examples here. The ATMM, this is the HI, our let's say thickest profile or with the highest depth. This would be the standard Yanisol 60 mm depth. So here you see standard, or let's say the maximum depth, glass thickness on Yanisol would be 46. On the HI, it goes to 54 or even more. I think it depends which glazing bead you take. Here you even have more flexibility. Okay. But generally, we can cover the whole glass spectrum that there is in the market. If you're really going for low values, then it makes sense to work on the with the HI. As you see here, it's a massive profile, but you get passive house values throughout the building. We sell it most of all in northern Germany, the Nordics, Scandinavian countries, where it's coldest. One more comparison to the aluminum system. Same values, or actually maybe not even the same values. Lower values on the Yanisol HI, higher values on the aluminum AWS, and of course much bigger face widths. So again, one more confirmation that steel is the material to go with if you want to achieve thin face views. Couple of examples. The IX values, the statical values, always given for each profile. They are higher on the HI than on Yanisol, but of course this is due to the massiveness and the geometry of the profile. Doors. This is just an example. I've seen much bigger doors on HI. Again, here 230 for a standard door, 2 hinges. That's doable with HI. With aluminum, you would have to go much higher, 5 hinges. That's usually what you work with. So to sum it up, today we have basically these these three insulated systems, thermally insulated systems in the portfolio. Yanisol, standard, let's say that the flagship of the portfolio. The Primo, the older one, and the HI, the high insulated one with the passive house certification. Besides that, we also have the Arte 2.0 and Arte 66 profiles, which I would love to show you before we go to the workshop. These are the elements of the HI. Well, the threshold profile, there is some PU, polyurethane foam, that you insert in here to reach the maximum values. And I think, Dave, I know what you're talking. Are these also the silica material that we see here?
Yes, if you look at the spacer bar at the top between the glass,
Porous.
then it looks like it's got pores.
Yes.
That's where they've got molecular sieve. Those are actually little small balls of molecular sieve.
Okay, so this is where it's used. Okay, I see. Okay.
And then what they do, they drill holes into that spacer bar, and then that pulls the vapor out of the glass cavity.
Okay. All right. What else is good on the HI? Well, this next few slides will be we'll hover around the HI possibilities. Easier to install. The closers are easier to install. The notching out is much easier because you work in the insulator, so in plastic, not in steel. So this profile offers a lot of advantages here. You can bend it as well, so that's not a problem. You can bend HI, you can bend Yanisol. All this is possible. And here it's an example of the minimum radius of each profile, as you see. This will tell you, how tight you can bend it. And the rule of thumb is that the smaller the profile, the more you can bend it. Glazing beads, exactly the same. Okay, this is an example of a door which was installed in Belgium in a kitchen studio, 6 meters by 2, I believe, 1.6 by 6. It's a cladded door, so metal cladding insulation on the top and on the inside. And in the winter, when this door was installed in summer, when the winter came, the owner actually installed a back entrance door, because he figured, when I open this door every time when the customer comes in, all my heating is out. My heating bill will skyrocket. Yanisol lift and slide doors, possible. We have actually a special profile for this combination profile in the bottom here. The frame profile is a combination of both. They also have a drainage system inside, a labyrinth system. So again, triple glazing possible, values up to 0.9, so passive house values on the lift and slide door. So.
Andreas, has the Yanisol lift and slide been popular or not so popular?
They're quite expensive. So they are popular in upscale residential constructions. I've seen them, but I mean, you have to really, I don't know how much a door like this. I mean, the standard terrace door, probably 10,000, 15,000 US. That's what you have to count on, versus maybe 5 in wood and aluminum. So that's the difference. Yeah, lift and slide. This is the cross section of the profiles. These are good profiles, elaborate to make, but it works pretty nice. And here is an example where we see them in action. This is a private villa. I guess this is somewhere in South America. But again, this is Gary's domain. Folding wall. We talked about this already. Again, some cross sections. Here, a view of a house. Folding walls were built. Renovation, just briefly about Arte 2.0. This is the newest system. I guess you have samples based on Arte 2.0, if I'm not mistaken. This system was born really in 2011, improved, and finally launched in the last version, today's version in 2017. What it features is very slim profiles. You see here the shape of the profile is totally different. There is no chambers. There is actually just a thick insulator connecting two small steel sleeves, you could say, steel profiles. So there is much more insulator here. Good values, slim face views. Glass is up to 47 mm, I think. So also triple glazing possible, and very neat appearance. I mean, this is what you see here. Yeah, this is it. This is the today's systems. It features a regular groove for the gasket. In the past, we had to use lots of agents and additional profiles. So today we are just left with the gasket. It's a fully grown-up adult system with all possibilities. That's the Arte 2.0. Materials or documentation is still available for the older versions. They are still in use. We still have profiles, but I always recommend the 2.0, the latest version.
Components.
It's protection.
Okay, couple of characteristics here. It's a lot of information. I just want to mention it's really a system that offers a lot of different exotic opening types. So you see them here: side hung, bottom hung, inward, outward, horizontal pivot, projected top hung windows. So tons of stuff you can do with this. Quite big weights here, 150 for a leaf, which for this thin profile is nice. Big sizes, 1 by 240. So this is probably something that you would love. I mean, I see this is the fastest growing profile we have.
Yeah, so it is my favorite profile. So the one challenge we have, I was just talking to Hillary about it, that we need to lobby our government because they've got duties of 15 to 20% on those profiles.
Oh, okay.
And the reason is because they've had value added to the raw steel, to the profiles.
Yeah.
So the protection is an issue, but it's silly because it actually helps to preserve energy. So we're going to try and lobby government and see if we can get it reduced.
Okay. Yeah, that's a good way to do it. Yeah, and the system is great. I mean, this is also my favorite. If I had enough money, I would do Arte 2.0 in stainless steel in my house.
Beautiful. Have you done that?
No, I have not. And in fact, I will start building a house this year, so I may, but probably my budget will not be enough to do this in Arte. We'll see. Okay, the dimensions here quite large as well. Here you see some examples. The presentation features a lot of different sizes. I will just flip through it because we actually have to go to the workshop very soon. Performance values, this is all in the catalogs. Good values. Arte is really a grown-up system. Lots of opening possibilities. Here you see them, combination with fixed windows, tons of stuff you can do. And of course the different materials.
Have Andreas said the guys been making doors out of Arte or not?
They have on projects, but those will be again the window doors with window fittings, that size of a door. But I hear there is a project in development. We will launch Arte 2.0 doors as well. So I don't know when, but it's in the pipeline.
Yeah, so I'm hoping that with that comes the lift and sliding doors come with that. Because I think hopefully you guys are working on something like that as well.
Could be. The lift and slide door on Arte, I haven't seen it in the development roadmap. It would be nice. There is a slider on Arte, based on Arte, but not this lift and sliding door yet. Yeah, we can't do everything somehow with only 1,000 guys. Okay, this is just a picture of what to use for the Corten. If you have a Corten steel, we have an oxidizing agent that you apply on the surface. The best is the foam roller. The spray bottle does not really work. So if you have a Corten profile, then you want to activate it, use the foam roller.
And is that the after manufacture?
This is, well, the oxidizing agent we provide. This is a Janssen product, and the roller is freely available in any market. It's just a foam roller.
Yeah.
This is how the Corten, actually, the chemical reaction between the Corten protection. It forms a rust layer or a oxidized layer This layer is very dense and very rigid, so it will not break off, it will not peel off like the standard one, and it will protect the steel from rusting through. This is how it works. It's also described in very detail in our documentation. Profiles of ART 2.0, many of them, different materials. By the way, here the ending at the item number gives you a hint on what kind of profile this is. The ending without anything after the 3 digits, so there's always a 3-digit dot and 3 digits. That means it's a raw steel. The Z is the ZF100, the zinc-coated steel. 01 is stainless, and 09 is corten. So this is
voila.
the information hidden in the profile.
It's 042.
I'll check the job.
Okay, that's in 3 languages, so we can just watch one. The difference between the old zinc coating and the new one, the ZF100, you will see the difference when you weld on it. You can directly weld on the ZF100. You don't have to remove it, you don't have to grind it off. The difference is less pores, less smoke, and a much cleaner welding. No need to grind it off. So here you see the difference. Yeah, that's a big progress here. We are using on all our profiles except the FIS profiles. They are still not being converted. We use this new coating. The new coating is a very thin zinc coating, 7 microns. And after applying the zinc, the profile is heated up. It's baked again, just like a car chassis. This technology comes from the car manufacturers. So what you have on top is not really a zinc layer, but it's an alloy. It's a steel zinc alloy that forms on the surface. That's why you can weld right on top of it, and no need to grind. And you see here the difference. It's much cleaner, less pores, less afterwork.
Does the finish look like that?
We polish it off. Okay.
Okay, profile, the Arte profiles, just inside, lots of glazing possibilities, standard glazing beads, well, with the spring in this case, or drill through, or you can use the so-called Reno seal. This is, well, like a patty, like a window patty that you put on top. You use angles here and close it with the patty. The nice thing is you can, excuse me?
I say no way. That's like old school.
But
cool.
Look at this. This is what they want. This is what's desired oftentimes. If you do renovation, like a church window, this would be exactly what they would do.
Unbelievable. That's actually, I can't believe I didn't know this. Brilliant.
Like putty like.
Yeah. And can you paint it?
You can paint it. Yeah, you can paint it.
Genius. Genius.
Came also from the Netherlands invention. They love it.
Yeah, the Dutch have a bit of innovation.
And with that, by the way, you can actually go on the Arte to class RC, the burglar resistance class RC3, which is pretty good on this thin profile. If you use this type of sealing, it's difficult to break through. Okay, couple of objects here, a couple of projects that we made based on Arte. Beautiful, beautiful. This is a private residence. This is the Regent Street in London, one of the hotels on the Regent Street. The whole facade was done with Arte 2.0. A couple of winter gardens. I'm speeding up because we need to go to the workshop in a few minutes. This is an example from an architect from Canada that equipped his house with an Arte window. This is the window. He used a massive steel frame though for this one. This is the opening mechanism. He is also a railway freak, so he likes the bells. And this is how the window is open. His 8-year-old daughter with a broken leg, so it's really easy to open. But once you see his terrace, you will understand why he did it. And this is the double speed. This is it. That was his originally the idea to open it with a sack full of sand. We convinced him to do an automatic or a mechanical opening here. That's the view of the house, and that's the view on to the outside. So yeah, not bad.
Beautiful.
Few more things. Okay, that's just an example that steel oftentimes is the only way to go if you want to have a small window, for example, narrow window. That's what you get from the. This is the original wood window. This would be the minimum or the possibility with plastic window, and with steel you get the real stuff.
Ridiculous.
So this is it, guys. We have to go to the workshop.